Let's talk about the binomial theorem and expand x plus y squared. We have x plus y squared, which is x plus y times x plus y. So x times x is equal to x squared. We have x times y, and we also have y times x. And then finally we have y squared. Okay, so x and y and x are the same result because of the commutative property of multiplication. So we have x squared plus 2xy, and then we have y squared. Okay, let's expand x plus y to cubed. So we have x plus y, and we already have x plus y times x plus y. It's up there. So we have x plus y times x squared plus 2xy plus y squared. And so we have x times x squared is x cubed. X times 2xy is 2x squared y. X times y squared is xy squared. And let's distribute the y then. So we have y times x cubed. And then we have y times 2xy. And we also have y times y squared, which is y cubed. So this simplifies to x cubed plus, we have 2x squared y plus an x squared y, so that's 3x squared y. And the next term is xy squared plus, you can see y 2xy is same as 2xy squared, so that ends up being 3xy squared. And finally, we have the y cubed. Okay, let's expand x plus y to the exponent 4. You'll have to trust me on this, but I'm going to just do this very quickly. What about exponents less than 0? Well, x plus y to the exponent 1 is x plus y, which is 1 and 1. And x plus y to the exponent 0, anything to the exponent 0 is 1. Many cultures knew about this pattern, but Blaise Pascal, the French mathematician, took the coefficients of the binomial expansions, starting with 0 and going up, that it started to have a pattern. That in row 1, where the exponent is equal to 0, you would just have the coefficient of 1. In row 2, you would have coefficient 1 and 1. So we could say, well, there's a 1x here, 1x here, and 1y, and that turns into this one and this one. And then continues on where this row 3 is 1, 2, 1, and then row 4, which corresponds with this corresponds with the expansion of x plus y to the 3, and this row here, which is 1, 2, 3, 4, 5, the fifth row, actually corresponds with x plus y to the exponent 4. And so these entries in Pascal's triangle are the binomial coefficients. Let's say the coefficients of the fifth row is 1, 4, 6, 4, 1. And remember that corresponds with the exponent 4. So actually we're saying is 4 choose no y's, no second term, and then 4 choose 1. This is 4 choose 2, which is equal to 6. 4 choose 3 is equal to 4, and 4 choose 4. We know how to use the formula for combinations. Remember that the formula for combinations is n factorial divided by n minus k factorial and k factorial. So this is what n choose k is equal to. And remember that we might be saying, well, the k plus 1th entry in the row, what does this mean? Well, because we have the exponent 4, but you're actually starting with choosing no y, so that's why it starts at 0. So 0, 1, 2, 3, 4, and that's why there are 5 entries in the expansion with the exponent equal to 4. The binomial theorem and a formula to expand a binomial to a certain exponent. Now this is the summation symbol, which means that there is a whole bunch of terms that are added together, starting with k equaling 1 and going through 0, 1, 2, 3, all the way up to n. We have n choose k, this is the combination of how many of the second term we're going to be selecting, and this is the first part with the remaining exponent, and then if we are choosing a certain number of y's, then we have k as that number on the exponent of the second part. So I'm calling x the first part and y the second part. So this really ends up being, well, let's just go through this example and we'll walk it through. So x plus y cubed means that we can choose, starting using 3, we have 3, and we're going to be choosing no y's to start out with, which means that everything is the first part. So that's 3. And then secondly, we're going to be adding to that, we're going to be choosing one bracket to have a y in it, and that means the rest of them will be x's. And then we have 1 y. And then we're going to be, out of 3, we're going to be choosing 2 brackets to have the y in it. So that means there's only one first part remaining, and then we have 2 of the second part. And finally, we've made it all the way to the end where we have 3. We're choosing all 3 to have the y, the second part. And so then that means we can say that x is 0, but of course anything to the exponent 0 is equal to 1, and then it's all y's. So what is 3 choose 0? 3 choose 0 is 1, so we can say that's 1x cubed, and then 3 choose 1 is actually 3, and that's x squared y. 3 choose 2 is also 3, and we have x with y squared. And finally, 3 choosing 3, that's equal to 1. 1 times 1, and then we have our y cubed. So this corresponds with our expansion of x plus y cubed in the traditional method of distributing through, but we can now use the binomial theorem. We're going to try to determine the coefficient of the fourth term of x plus y to the 7. Now this exponent is getting higher, so it's going to take a lot of time to actually write out all the terms. So let's see what this fourth term is. There are going to be 7 brackets, and we're going to see this pattern. We're going to choose no brackets to have the second part in it, or the y, and then we're going to have, and then there's, of course, there's an x and a y part, but then the other coefficient is going to be 7 choose 1, and so on. So really it's going to be choosing 0, then 1, then 2, then 3, and then 4. But what would be the fourth term? Well, we see this is the first term, this is the second term, this is the third, and this is the fourth term right here. The fourth term. So we can see that because we're starting at choosing 0, 0, 1, 2, 3, this n choosing 3, well, this n is 7. 7 choosing 3 is actually the fourth term. So this is the start. So we can say that the fourth term happens when we say out of 7 brackets, we're choosing 3 of those brackets to be using the second part, the y value. That means the remaining 4 come from the first part, and the second part is equal to, we have 3 of them. So this is the whole term, the fourth term. And let's see, well, x to the 4 and y cubed, those are the variable parts. So we're going to say the coefficient part only comes from this section, 7 choose 3. Now, we may not know that right away, but we do know the combination formula. So 7 choose 3, that combination formula is 7 factorial over 7 minus 3 factorial and 3 factorial. And if we just continue, we could say this is going to be 7 factorial over 4 factorial, 3 factorial, and we could punch this in a calculator, but let's continue here. So this is 7 times 6 times 5 times 4 factorial, or 4 factorial, 3 factorial. 4 factorials will cancel. Now we know that 3 factorial is 3 times 2, so this 3 factorial actually cancels out this 6. So 7 choose 3 is equal to 35. So the coefficient of the fourth term is equal to 35. With the binomial theorem, we can expand it, well, pardon the pun, but we can go beyond just x and y. We can actually have a value for y. So we can say, well, this traditionally would be like x plus y cubed, or sort of y to the 4. But this y is actually now a positive 3. Okay, so let's do this traditional method. We can say, well, this is going to be 4 brackets. So it's going to be 4, choose 0, with x being everything. And then what is y, what used to be y, and it's going to be have none. And then 4, choose 1, x 1 lower, and then have y show up 1 time. And then 4, choose 2, x squared, y squared. And then we have, oh, actually, let's put that in brackets. And then we have 4, choose 3, just 1x now, and then this y is cubed. And then we have, finally, it's all y's. So x to the 0, but I'm not going to write it. Well, maybe I should. X to the 0, and then y to the 4. Okay, well, this part is, we can say 4, choose 0, that's just 1. And so we really have x to the 4. And I think we can say that this y to the 4, we kind of see that pattern. Now, this 4, choose 1 is equal to 4, so we can say that that's 4. The x cubed, we can write as x cubed, but these y's are no longer y's. Actually, we can replace this y is now a 3, and this y is a 3, this y is a 3, this y is a 3, and this y is a 3. So we can actually say, okay, well, this is just 1. That's 3 to the 0 is equal to 1. But 3 to the 1, that's equal to 3. And notice now that this number is going to join this number in the coefficient. And of course, this 3 squared is going to be 9. This 3 cubed is going to be 27. So notice that once it becomes a number, it's going to join with the number that came from the combination. So here we have 6x squared 9 plus, this is going to be 4x times 27. Let's put that in brackets. And now we can say, well, this is equal to x to the 4 plus, now 3 times 4, that's 12x cubed, plus 9 times 6 is equal to 54, x squared, plus what is 4 times 27? So it's 80 plus, so 108 x plus, oh, I forgot to change this into a 3. So let's make that a 3, and this is going to be equal to 81. Now, so we have this expansion of x plus 3 to the 4. So now we've gone beyond just having it as variables, but we can actually replace them with numbers as well. So that's the gist of the binomial theorem practice, and I will see you in class.